it is difficult to hold an inflated plastic ball under water. Okay, so we know an inflated plastic ball will have some air particles inside it, and we need to talk about why it's difficult to keep it underwater. So I'll give you the model answer now. Okay, so I'm going to first of all draw my diagram. So here's question 1. Here's my ball, here's my water, and again we're trying to push it down, but I'm going to say there is obviously water pressure here. So here's my water pressure, or pressure from water molecules underneath, and then here's my atmospheric pressure. So atmospheric pressure, first of all, is going to be less than the water pressure. So we need to talk about this difference in pressure difference. So first point I'm going to say, pressure on lower half of inflated ball, okay, is greater than the pressure on the top half. And as a result, this means and bear in mind, what did we say? Pressure was force over area, right? So effectively the cross-sectional area, so this cross-sectional area is equal to this cross-sectional area. So we were assuming it's a cylindrical symmetrical ball here, of sphere, and if the surface area is the same on the bottom half as well as the top half, well, A we can assume is a constant, therefore it's effectively a difference in force, isn't it? So we have greater force on the bottom and we have less force on the top, so therefore we're going to have a resultant force pushing upwards, and that is known as the upthrust force. So let's mention that. So we're going to say this means that the ball will experience an upthrust force. Okay. Now, the question says why, however, we also want to talk about this idea of the weight of the fluid being different. So I'm now going to put those points down. So we have to say, first of all, the volume of liquid displaced by the ball is equal to the volume of the ball. Okay, because the question has told us it is fully immersed, but they're saying why is it difficult to fully immerse it? Well, but we know that if it has been fully immersed, well, it has displaced the same amount of volume that the object is. Okay, so that's all we've stated there. Okay, so jot that down. However, the next thing we need to mention is because the water is more denser than air, okay, the weight of the liquid displaced will be greater than the weight of the ball itself. Okay, so let's write that down. However, as water is denser than air, the weight of the liquid, which is the water displaced, than the weight of the ball. And this links back to our sentence we said earlier on. If an object floats, its weight will be equal to the upthrust. Okay. However, if it sinks, its weight will be greater than the upthrust. But in this case, we're saying that the weight is less than the weight of the water displaced. So therefore, it's going to the upthrust force is going to be greater. Okay, so let's put that as our final point. So we can say the upthrust force will be greater than the weight force of the ball.